I was trying to make a trefoil knot, I did not have time. So, that is what I am trying to do it again first. Okay. Let me make the cartoon maybe first. It goes this way, comes this way and goes this way. The other one will be opposite. It comes below and then goes above and comes like this. Okay. So, this one is below, this one is, let me do. Like this, another one is like this. Okay. This is, forget this is, it is somewhat difficult to understand or do it. So, we got this cartoon. Now, I have to describe it properly. You pay your attention, this one is up, okay. Which is up? I am writing a maybe a this mark up, and this is down and this is up. Okay. There are two flexible units, if you may envisage, where one is up and then going down, the other one is, it was down and then going up. So, it is like this, and the other one is going down and coming up. So, this is the configuration. Now, if I clip it, how I am going to clip? I can clip is this side also, this side. If I do that, then I get ended up as a huge macrocycle. I do not want that, I want trefoil knot. So, what I will do? From molecular mechanics, we know the distance. Okay. So, we get a particular ether, linear ether at the other end, at the two ends maybe iodine, so that it easily form compound. You remember the catenane that I described earlier with copper 1. So, it is similar to that. And so, this is my linear part and this is the linear part. Okay. So, this linear part, now if you do it like this, then I am getting this particular trefoil knot. It is not, it is kind of difficult to visualize, but if you do it at home with maybe 2 threads, 2 people will doing it with 2 threads and all that, then you can understand is really this one will boils down, this one comes to this trefoil knot. So, therefore, what should be my molecule? My molecule should have a binding site. This is a binding site and is a side chain for functionalization. So, binding site which is very rigid with another moiety here for functionalization, maybe I will write F, and then I have flexible part, because one will going down coming up. So, it needs flexible part, and then what I will have? I will have another binding site and then functionality here. Okay. So, therefore, what will happen? When 2 molecules like that come close to each other, then because of this copper 1, it likes tetrahedral. So, this one will be up. So, copper is here and then it goes down. This was up, this was down, this is up. Now, this is up and going down, up. This is down, this is up, okay, up and up, okay, up and up. So, then I can put yellow with green this way and I can put this and here, okay, copper here. If I do that, then I am going to get this particular compound, because once we take out the metal, we get that. So, let us see what is the compound. It has been synthesized. What is my problem? To draw always problem. Okay. Nitrogen, I will draw like this. Nitrogen, I am drawing the double bond later. Okay? All right. So, I will check and then put accordingly. This, 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 this and this. Okay? No, already messed it up. Yeah. Nitrogen here. Here also I messed it up. Okay. See, no matter what you draw, what you make, the valency must be satisfied, and also there cannot be two side by side double bonds. So, this compound. Now, I am okay with double bond. Double bond I should write at the end, then this problem does not appear. Then 1, 2, 3, 4, 5. Okay. Then 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. ठीक, all right. It is all right. Again the rigid one. I have come to the rigid. My N is not very good looking. Okay. Yes. Okay. So, this is the compound. Binding site rigid. Okay. It is like this. It's looking so bad. Let me draw it well. Now it is all right. And then it will all screwed up. All problems. Now it is okay. Okay. So, this is a binding site, and copper, if you put copper 1 and copper 1, what they will do? They will bind another one of this. So, this will be coming here from top, and then we are hoping that, it is just hoping that it will go down, down, and again it will bind, and then it will come here. Okay. The other this one 2 is to 2 binding. And why that will be happening? Because of its flexibility. But this, as you can understand, this is a very, very difficult, and copper actually acting here as a kinetic template, because it is making it, forcing it to be tetrahedral, 1, 2 and then 2 nitrogen becoming tetrahedral, and here also tetrahedral. That is why this is up, going down and again up, and this is going down, up, going down and again up. Okay. Up, down, this is down, up. So, that way it forms, and then I am going to close it to get, and then I will get rid of this copper, then I get what I am going to get? Trefoil knot, that is it. Okay. So, these knot compounds are over. Right now, I will be talking about dendrimers. So, dendrimers, highly branched dendrimers. I promise you, this is my last molecular description. I will go to their uses now. Dendrimers, they are highly branched polymers. Highly branched monodisperse polymeric material. Polymeric materials. Okay. And structure of these dendrimers, I will write one structure right now, is found has a great impact on their physical and chemical properties. So, these dendrimers have found some usefulness in biomedical and industrial applications. So, now dendrimers has in their structure, it has a core. Let me draw a core. Core I am writing G0, means 0 generation, and then it will branch out in in all directions. Okay. So, this one is G1, G1. Okay. So, this is G1, then I am writing G2, G2, G2. It's difficult to fathom, but it will be easy, not that big a problem. Okay? This is G2. Then I am writing, or maybe I should write this as G2, otherwise you are getting confused. This is G3. This is G3. This is G2. Then G4. You can understand that we are stopping, we have to stop here. We are forced to stop. That is called periphery. At the periphery, we are forced to stop because they are coming closer and closer. Here I have gone up to G4, followed. So, these are generation number, first generation, second generation, third generation, fourth generation, and this is the core, okay? And this is called the inner cell. Here is the inner. So, this inner part has molecular recognition points, so that a guest can come inside also. If a gas is come inside somehow, so it is a 3D structure. You can understand that. It is like a ball. If you take a ball, in the middle of the ball you have that core, and then it is coming in 3 directions. Then what will happen? It will happen something of this kind. I am writing. Okay. First, let me write the reaction. Simple compound ethylene diamine. Ethylene diamine, okay? Or you can take, in this case he took propylene diamine, no, diamino, yes, propylene diamine, 3, 1, 2, 3. One 3 diamino propane. Okay, 1, 2, 3, or say sometimes you can keep butane, it does not matter, all right. And he took actually butane, actually he took butane. If you react this with 4 equivalents of this compound, this nitrile compound, then what happens? It happens 1, 2, 3, 4, 4, 4, N, Cn. So, the hydrogens of the amine are replaced by this moiety. Okay. We add this cyanide. So, this compound we found, and then if you then what I do? We reduce it with Raney nickel. Raney nickel. Okay. He uses Raney cobalt. Raney nickel or Raney cobalt. Here I will write cobalt because it is written here. Raney nickel will also do. Okay. Hydrogenation. Then what will happen? I get 1, 2, 3. 1, 2, 3. 1, 2, okay, 2, 3. Then I have here 4. 1, 2, 3, 4, n. Then I get 1, 2, 3. This compound we get 1, 2, 3. So, cyanide become CH2NH2 and then these two. So, there are 3 carbon, that is why 1, 1, 1, 2, 1, 2, 3. How come there are 2? This is 1, 2, 3, this 1, 2, 3. Okay. So, like that it keep on going. So, we keep on going this reaction, what we are going to get at the end, that is what I am trying to write. I will not be able to write, but at least I will try. 1, 2, 3, 4. 1, 2, 3, 4. Then you have 1, 2, 3 nitrogen. 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 Then I will have 1, 2, 3 nitrogen. Then you will have 1, 2, 3 nitrogen. Okay. Then what I will have? I will have 1, 2, 3 nitrogen. Same thing, after amine you reacted with that nitrile compound, 1, 2, 3 nitrogen. Then I will have 1, 2, 3 nitrogen. Then I have 1, 2, 3 nitrogen. Then what you will get if you do not, if you continue like this side also 1, 2, 3 nitrogen, then 1, 2, 3 nitrogen. Then again it will go. Then what you get? You get a huge ball, okay, and that is called dendrimer. So, you get a dendrimer, and what I just showed you, this method of synthesis is called divergent method. Divergent method. Okay. This is a divergent method of synthesis of this compound. This goes on, here also it will go. So, it will go on like this, this will again go and it will stop, at some point it will stop, because they are almost touching each other. So, they cannot go on like that. So, after certain generation it has to stop, all right. There is another called convergent method. Okay, before I go to convergent method, these things are called, see this one part, this one part attached to this core, this is core. So, this called dendron, this thing called dendron. Okay. So, this dendron, all right. So, in convergent, this is from in to outside and convergent is from outside in. Okay. So, now let us see, we make dendrons first and then converge it. Okay. First make a dendron. Me3. Okay. So, this one on reaction with this reagent, in presence of palladium 0 catalyst and sodium carbonate. What you get? Then we react BBr3 alkaline and then again add this catalyst . Sodium carbonate, and plus we call it A. So, plus A. So, this with this we add A means this part and then try this. So, then what will happen? It will make phenyl-phenyl bonding. So, finally, we get this particular compound Si-Me3 okay. All we are making is a dendron kind of stuff. Okay. And here also okay. So, we get this, then what? Then again we go to this step BBr3 and all that. Then I tried BBr3, KOH, one, two, and then 3 is palladium 0 catalyst PPH3 tetraphenyl triphenyl phosphine tetra, okay, and then sodium carbonate, okay, plus we add this tribromo compound. This is my core. This is my core. So, once I make this core, then what I am going to get from this core, okay, I am drawing only one. Let us draw like this. Okay. Okay. Meta, all right, and here also. So, we get like this, here we get like this, we get this part, okay, this part we get. And then this has the center one, okay. So, this part we get. So, this dendron we make and then we put it, hook it up with this compound and ended up here also we ended up here, okay. So, all these 3 parts we get like this. This way you keep on, again you can extend like that and you can get like that. So, this is dendrimers and we can, and these are periphery. So, at the end we call periphery. The periphery can be functionalized, okay. Periphery can be functionalized to giving it new and new properties, all right. So, therefore, with this I have completed all the most of the synthetic supramolecular synthon, the tried to make some representative compounds I showed you over the last few lectures. So, from next time I am going to use them, okay. I am going to use them in supramolecular situations. How? So, that comes from tomorrow onwards, we will discuss that. We first take fluorescence, first take up fluorescence for our study. Okay, thank you very much.